Hello students, welcome to today's class in which I will teach you all about the computer system organization. The computer system organization is the internal structure of the computer, and it is composed of many parts such as the CPU, the memory or RAM, the storage controller which manages the hard drive, and the input-output device controllers which manages all input-output devices such as the mouse, keyboard, printer, and monitor. However, these objects need to be connected to each other to function properly, which is exactly the purpose of the system bus. The system bus is a pathway composed of cables and connectors used to carry data between a computer microprocessor and the main memory. The bus provides a communication path for the data and control signals moving between the major components of the computer system. The system bus works by combining the functions of the three main buses, namely, the data bus, address bus and control bus. Each of the three buses has its separate characteristics and responsibilities. The first bus we will talk about is the data bus. The data bus is a system within a computer or device, consisting of a connector or set of wires, that provides transportation for the data. A data bus can transfer data to and from the memory of a computer, or into or out of the central processing unit, CPU. The second bus we will talk about is the address bus. The address bus is used to specify memory locations for the data being transferred, which is stored in the form of binary numbers to enable the data bus to access memory storage. The third bus we will talk about is the control bus, which is the bus responsible for communication between the devices that are contained within the computer. The speed at which information is exchanged between components is regulated by a bus controller. Information coming from the CPU, for example, will always travel at a much higher speed than data coming from other components. Now let's talk about the Central Processing Unit, or CPU for short. The CPU is the main component of the computer, and is the unit which performs most of the processing inside a computer. It processes all instructions received by software running on the PC, and by other hardware components, and acts as a powerful calculator. There are two types of processing systems: single processing systems and multiprocessing systems. Single processing systems are always composed of only one processor, which results in it only being able to execute a single operation at a time, and must complete the current operation before being able to start another one, and the new operation must be in the ready queue. However, single processing systems are rarely used these days, because they are outdated compared to multiprocessing systems. Multiprocessing systems are systems composed of two or more processors, and are much faster than single processing systems and pretty much replace them, because multiprocessing systems can execute multiple processes at once. Another benefit of multiprocessing systems is that almost all major operating systems support it. For example, Unix and Windows both support multiprocessing systems, and do not support single processing systems. Multiprocessing systems resources are distributed by their operating systems, which distribute resources to the operations by allocating more resources to the more important operations, while the less important ones get less resources, which also makes them more complicated than the single processing systems. However, the main drawback with multiprocessing systems is that with too many processors, the system bus becomes a bottleneck and performance begins to degrade rather than improve. To combat this, each processor was provided with its own local memory that is accessed via a small, fast, local bus. This approach is known as non-uniform memory access, or NUMA. And that is the end for today's class. Hope you had a good time, and see you later. Goodbye.